Hi guys, welcome back to the channel. So in this video what we are going to do is, the question is, given a number n, we want to print odd and even number using two different threads. Okay, and they have to do one by one. So in my previous video I have shown how we can use a synchronize keyword for this purpose. Now in this video we are going to use a reentrant lock. Okay, so reentrant lock was introduced in the Java version 1.5, and it was having the same feature as synchronize, but in addition to that it gives you certain more parameters to define how the lock mechanism will work, and also it gives you more flexibility. So one thing which we can see before we start coding this example, we can see that if you create a reentrant lock, okay, you can pass a parameter fairness. Okay, so it is having one of this constructor which is taking this fairness. So what does it says is, so let's suppose a hypothetical example where you have 10 different threads and they are waiting for a particular lock. Okay, and if this fairness is true, what it will do, it is giving you certain guarantee that the thread which is waiting for the most period of time, that will get the lock first. So this is that fairness. And similarly there are uh, there are a lot of other method as well, like you have a try lock. Okay, you have try lock with time. Okay, you also have a hold count method, and also you have something called as condition that we will be using in this video. Okay, so it does the same work as synchronize, but it has some additional methods which we can leverage. We will be using this lock, reentrant lock. Okay, so based on that we will create a conditions also, and by that we'll see how two different threads can actually communicate. So we can solve this problem using multiple ways. We can also use semaphore, that we will see in another video. I have already shown you how to do synchronize. Okay, so let's start coding. Okay, so first of all what I will do, I will start creating my worker class. So when we want to create a thread, right, there are two different ways. We can actually implement a runnable interface and override this run method and do our coding, or we can actually extend a thread class. So in future I will also tell like what are the difference between runnable and a difference between a runnable interface and just extending a thread class, when we should do that. Okay, okay, so what are the parameters I will take? Private int n, up to how many numbers I want to print. I will take private boolean is odd. It will tell whether this is responsible for odd numbers printing or not. I'll also have a condition. Okay, and I'll also have a lock object. So these are the parameters I will be taking. Generate a constructor select all. Okay, we got it. And if it is odd worker, else even worker. So before we start coding this, just want to tell you that this is not the only purpose of reentrant lock. Okay, we can leverage this for so many things. Here I am just showing you how the two different threads can actually communicate. Okay, if they are using a reentrant lock. So there is one more thing when we are using a synchronous keyword, right? Or in that case, you will create a method with a synchronous keyword, or you will have a synchronized block inside a method. So you don't have to have a try catch block, okay? But when you are using a lock, right, you should have a try catch block, or at least you should have a try finally. Okay, the purpose is when you are acquiring a lock, you want to release that lock as well. Okay, so even if there is a your program is interrupted because of anything, or like there is any exception here at this place, you want to unlock that lock. Okay, so that we will always be in a consistent state. Okay, so we will acquire a lock, and here we will always unlock it. Okay, I will have a just I will do a while, just initialize this with 1, and while it is less than equals to n, and if this is to check if the number is even, and then we'll say even print I. In every case I want to do I plus plus. Okay, so when you are using a synchronize, right, and you are not using a reentrant lock, then how the your threads will communicate with each other using wait and notify. Okay, so reentrant lock gives us something called as conditions, so we will be using conditions in this case. So if you have worked with queues, blocking queues in Java, so you will be aware how these conditions are actually used. So in that case, they have put and take method. Okay, so put is the method like um, which is actually putting an object in the queue, and take is when you are taking the object, like you are retrieving the object from the queue. So what happens, they actually use these conditions. Okay, so they have a lock object and they use these conditions to communicate with each other, because if there is no element in the queue, then your threads will keep waiting. Okay, in a producer consumer problem. So it is similar way I am trying to use those conditions here. Okay, so I have two conditions, right? So even worker, so when this even worker, let's suppose it has printed a number, then what it will say, it will say odd condition dot signal. So this is the method which will actually notify if any of the method, like we have wait and notify, right, in normal case. Similarly, this is like equivalent to notify method. So in this case it will actually notify this odd signal, like odd condition dot signal, that you can resume working. And what we will do here is we'll also see your even condition, it has to actually await. Okay, okay, it says I will do this, and what I wanted to do here is, like, if my I is less than equals to n, only then I want to call this await method. Okay, otherwise I don't want to call this await method. Okay, so this is, you are actually notifying the odd condition to resume working, and here you are actually saying just wait here. So when you call this even condition dot await, it will keep on waiting here until some other thread will say okay, even condition dot notify, then it will start resuming. Okay, so this is done. Similar thing I will use for my odd worker. Only thing is this, I will change this condition, say this, and here I will say even condition dot signal. So what it will do, it will actually signal that condition, and it will not stop its working. Actually, it will go here and it will actually call this method. Okay, I'll say odd condition dot await, so it will start waiting here and will notify the our even worker. Okay, you can start your working now. Okay, this is done, this is done. So every time first time we will acquire the lock, and if let's suppose any exception happens, we can come here, it will print the stack trace and it will actually unlock the. So now this is done. I'll just start coding here. I'll say integer n equals to 10. Say reentrant log dot how we'll get the condition, new condition. I can say this as a even condition. This will be my odd condition. Okay, so I have all these things now. Let's create a pass this is this false even condition and my log object. Okay, similarly I will have my odd worker as well. So now I have two workers. Let's create the threads. This one like this. Thread equals to new thread odd worker. Sorry. We'll also have an even thread. We will pass here the even worker. Okay. So now first when you start the counting, right, from let's suppose in this case 1 to 10, you want the odd thread to start first, and then you want the even thread to start. Okay. So what we will do in this case is we'll say odd thread to start, and we'll say even thread dot start. We'll say odd thread dot join. Even thread dot join. Okay, and also print like when exiting. Okay, we have to handle this. I'll just include it here. Okay, so what is happening here is you will start the odd thread, you will also start the even thread. Okay, now these both the threads will actually start together. You can say like odd thread is starting first, but there is a possibility that even thread will start first. It can happen. Okay, so even if even worker has started, what it will do actually, it will come here, it will say okay, I equals to 1. Okay, this is a case where even worker has started, because JVM does not guarantee how your threads will actually work. Okay, so when it is 1, it will say okay, this number is not even. It will go and say odd condition dot signal. Okay, it will actually notify the odd thread to work. So even in our case, uh, even the JVM is not starting this odd thread as the first one, and even thread like is getting executed. In that case as well, we are pretty safe that it will actually work properly. Okay, so let me just try to run it. If it works, let's see what is the output we are getting. Okay, there is some issue. Okay, this is actually true. So this is some code mistake apart from the even condition. Okay, let me just try it again. Okay, so now it has started working. It was just a typo mistake. So now you can see that odd even are actually working in a proper way. We can do one thing, that we should try it running multiple times. Okay, so what happens, there is a guarantee that in a case your event thread will actually start working before, but it is not happening here. Okay, and it will not happen in this case, since we have taken care like how our program is actually working. So this is the way we can actually make this thing work via reentrant lock. You can go and check the documentation about reentrant lock and what are the best practices about it. This is not the only use of reentrant lock. It is used in multiple places where you want to acquire lock multiple times. Okay, and you can check all this in the documentation. Okay, thank you very much for watching this video. If you have any doubt or if you think that any improvement is required, please comment in the comment box, or okay, I will try to cater all those changes whichever is required. Thank you very much.